Hello everyone. In the last video, we have seen how to calculate the ultimate load carrying capacity of under-reamed pile. It was single under-reamed, it was double under-reamed, it could be multiple under-reamed. What do you mean by multiple under-reamed pile? When the number of bulbs are more than 2. So we would like to solve one problem on this. The load carrying capacity, we can find it out. The equation I have already given to you. And let's say the load is known. How will you design the under-reamed pile? So for the given load, let's say Q equal to 1000 kilonewton. And diameter of the pile, shaft dia, under-reamed pile, shaft dia of the under-reamed pile, or simply let's say pile D equal to 0.5 meter. And the ground conditions are also known to you. It is embedded in cohesive bed. So the pile has been embedded in the cohesive bed. Cu equal to 80 kilopascal. And we need to design the pile. Design single under-reamed pile. So it is going to be single under-reamed. So you can, whenever you try to solve a problem, always give a schematic that. Say this is the single under-reamed pile. This is the ground level, and the condition is given that the groundwater table is touching ground level. So water table is up to here. Naturally, the safe load is given to you. This is the load Q. This is the safe load of 1000 kilonewton. Therefore, the ultimate load will be factor of safety 2.5 multiplied by QC. So this becomes 2500 kilonewton. So for this ultimate load, you will have to shaft dia, you can show it here, 0.5 and this becomes 2.5 times the shaft dia. This is the diameter of the under-ream. So du equal to 1.25 meter. Having calculated this, now the ultimate load carrying capacity is going to be load carried due to a skin friction, load carried at the piles tip, and load carried by the bulb. So this is the axial load, 2500 kilonewton. This is known to you, and the value of QS you can calculate it. It will be alpha times Cu. The alpha is given over here, 0.6. So alpha times Cu will be the skin friction. So the skin friction can be calculated. And this is acting over the shaft. So perimeter pi d, and other than this under-ream, let the length be L1. So you can substitute the value 0.6 into 80 into pi into d into L1. Similarly, we can find out now QE. So the value of QE, which will be acting here, the total load which is going to come at the piles tip, is going to be QE into area of the pile at its ends, and it is given as 9 times Cu, that is the value of QE into pi by 4 into d square. So you can calculate this. And the third term is going to be load carried by this bulb, the resistance offered by this bulb, that is called QB, B for bulb or under-ream. This will be 9 times Cu into pi by 4 du square minus d square. So you can calculate this, 9 into 80 pi by 4. du is going to be already 1.25 whole square minus 0.5 whole square. So naturally, you can calculate this in kilowatt. All these are all in kilowatt. Is also in kilonewton. QS. Now, what is the value of QU? The value of QU of this under-reamed pile, QU of this under-reamed pile, if you substitute it, so QU of under-reamed pile is 2500 kilonewton. So therefore, the equation becomes like this. So 2500 kilonewton equal to QS, which you have calculated like this. This will be 48 pi into 0.5, so it will be 24 pi. L1 plus the another term which you have already calculated, you substitute it, so this you can calculate it, so 270 pi by 4, no, there is 9 8 is 72, so 720 pi by 4 into 0.5 square plus the QB value is 9 8 is if you simplify, the unknown L1 is calculated in meter. So that's the answer. So it's so simple to calculate the or design this. If L1 is given to you, then also you can calculate the ultimate load carrying capacity of the pipe.